Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video part 3 on the chapter rational numbers, I will solve the remaining problems, that is question number 7 to question number 10 of exercise 1A from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Mathematics for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start this video. Okay, so I have the exercise problems of exercise 1A. I will solve in this video. I will solve the question number 7, 8, 9 and 10. In the previous part 2, I solved the question number from 1 to 6. And if you have not watched the previous part 1, part 2 videos, then I highly suggest that you watch them also to maintain the continuity of your study on the chapter of rational numbers. So let's start solving the problems. Problem number 7. One second. I'm having a little bit problem with my canvas. Okay. So problem number 7 is fill in the blanks with the correct symbol out of greater than, equal to and less than. So we have to compare two rational numbers based on whether one is greater than or less than or equal to another rational numbers. So the rational numbers are this is part 1. We have to compare minus 3 by 7 with 6 by minus 13. So we have to, this is a fill in the blanks, we have to put something, the relational operator, that is less than or greater than or equal to. So the two rational numbers are minus 3 by 7 and 6 by minus 13. Now first we have to convert the two rational numbers to their standard form. So 3 by 7 is already in standard form, as denominator is positive and the numerator and the denominator, absolute value of numerator and the denominator are co-prime. 3 and 7 are co-prime, that is they do not have any common divisor other than 1. But 6 by minus 13, this is not in standard form. First we have to make the denominator positive, and so we multiply both the numerator and the denominator with minus 1 and it becomes minus 6 by 13. Now we see both the rational numbers are negative and the denominators are different. So first we have to find the LCM of the denominators 17 and 13. This will be 17 into 13, that is 91. So now we have to convert these two rational numbers to their equivalent rational number, so that the equivalent rational numbers will have a common denominator of 91. So when we do that, when we convert them, minus 3 by 7 will be minus 3 multiplied by, we have to multiply both the numerator and the denominator with 13. And this is 7 into 13, and this rational number minus 6 by 13, we have to multiply both the numerator and the denominator with 7. So this become minus 6 into 7 divided by 13 into 7. So now the pair of rational numbers becomes minus 39 divided by 91, and this becomes minus 42 divided by 91. So now we have the two rational numbers having the same common denominator, that is 91. Now we can compare them based on the numerators, and we know that minus 39 is greater than minus 42. So this will imply minus 39 by 91 will be greater than minus 42 by 91. So this implies that minus 39 by 91, the original rational number was minus 3 by 7. So this is greater than, and minus 42 by 91, the original rational number was 6 by minus 13. So we see that minus 3 by 7 is greater than 6 by minus 13. So over here, the filling the blanks, the relational operator should be greater than. Okay, so part 1 is done. So while I am solving the problems, you can pause the video and take a screenshot for your future reference. Part 2 is the numbers are 5 by minus 13 and minus 35 by 91. Okay. First, we have to convert the two rational numbers to their standard form. So 5 by minus 13, the denominator is negative. We will make the denominator positive. So it becomes minus 5 by 13 and minus 35 by 91. We can see we have to we see that this is minus 35 by 91 is also not in standard form, because the common divisor, the HCF of 35 and 91 is 7. Is 7, so it is not equal to 1. So we can divide to make it in standard form. We divide both the numerator and the denominator by 7. By 7, and so now the rational numbers, two rational numbers in standard form becomes minus 5 by 13. Minus 5 by 13, they are okay, so they are equal. Okay, so minus 5 by 13 and minus 5 by 13, the two rational numbers are equal, so definitely the filling the blanks, it will be equal to sign. So we have this relation between the two given rational numbers. Okay, let's do part 3. Part 3, it is minus 2 and minus 13 by 5. Filling the blanks, we are filling the blanks with less than operator, greater than operator, or equal to. Now first we will convert them to standard form. So minus 2 is minus 2 by 1 and minus 13 by 5 is minus 13 by 5. We see both the rational numbers are negative and the denominators are different. So we have to convert them to their equivalent form so that they will have a common denominator of as the LCM of 1 and 5. And LCM of 1 and 5 we know is 5. So when we convert these rational numbers to the equivalent form so that they both will have a common denominator of 5, it will become minus 2 will have to be multiplied by 5 and 1 multiplied by 5, and this is remains same as the denominator is already 5. So now the pair of rational numbers becomes minus 10 by 5 and minus 13 by 5. Now the rational numbers have same denominator, same common denominator, which is 5. We will now compare them based on the numerators, and we know that minus 10 is greater than minus 13. So this implies minus 10 by 5 will be greater than minus 13 by 5. So this implies minus 10 by 5, the original rational number was 2, so it will be greater than, and minus 13 by 5, the original rational numbers was minus 13 by 5 only. So this is the relation we get between the two rational numbers. Hence, in the fill in the blanks, the operator will be greater than. Okay. Let's do part 4. Part 4. Part 4 is minus 2 by 3 and 5 by minus 8. Minus 2 by 3 and 5 by minus 8. Now first we convert them, the rational numbers, to the standard form. So minus 2 by 3 is already in standard form, but 5 by 8 minus 8, we have negative denominator. We will make the denominator positive and it becomes minus 5 by 8. So now both the rational numbers are negative and we see the denominators are different. So we have to convert them to their equivalent rational numbers so that they both have a common denominator of a common denominator, which will be the LCM of 8 and 3, which is 24. So the equivalent rational numbers becomes minus 2 will have to be multiplied with 8 and 3 into 8, and this becomes minus 5 by 8. This rational numbers, numerator and the denominator, will have to be multiplied with 3. So now the rational numbers becomes minus 16 by 24 and minus 15 by 24. Now we see both the rational numbers have same denominator, which is 24. Now we will compare with the based on the numerators, and we see minus 16 is less than minus 15. So this implies minus 16 by 24 is less than minus 15 by 24. So this implies the original rational number of minus 16 by 24 was minus 2 by 3. So this will be less than, and minus 15 by 24, the original rational number was 5 by minus 8. So this is the relation we get between the two rational numbers. Hence, in the fill in the blanks, the operator will be less than. Okay. Let's do part 5. It is 0 and minus 3 by minus 5. Now this might be a little tricky. Now 0 is 0. The standard form rational number 0 is nothing but 0 by 1, which is in standard form. Now minus 3 by minus 5, the denominator is negative. So what we have to do is, to make it in standard form, we have to multiply both the numerator and the denominator with minus 1. So this becomes minus 3 will be multiplied with minus 1, which is 3, and minus 5 will be multiplied with minus 1, which becomes 5. Now we see that 3 by 5 is a positive rational number, and 0 by 1, 0 is 0. So definitely 0 is less than 3 by 5. So in the blanks, the relational operator will be less than. Okay, and we have part 6, which is minus 8 by 9 and minus 9 by 10. Now both the rational numbers are already in standard form. So we see the denominators are different. So we have to convert them to their equivalent form, and so that both the equivalent rational numbers will have a common denominator as LCM of 9 and 10. LCM of 9 and 10, which is equal to 90. So the equivalent rational numbers will become minus 8 multiplied by 10 and 9 into 10, and minus 10 by minus 9 by 10 will be minus 9 into 9 and 10 into 9. So now the pair of rational numbers becomes minus 80 by 90 and minus 81 by 90. So now the rational numbers have equal same denominator, which is 90. We can now compare them between based on their numerators, and we see that the numerator minus 80 is greater than the numerator minus 81. So this will imply minus 80 by 90 is greater than minus 81 by 90. So this implies that the original rational number of minus 80 by 90 was minus 8 by 9. It will be greater than the original rational number of minus 81 by 90 was minus 9 by 10. So we get the relation between the two rational numbers. Minus 8 by 9 is greater than minus 9 by 10. So in the fill in the blanks, the operator will be greater than. So we completed question number 7. Let's do question number 8. Question number 8 says, arrange the following rational numbers in ascending order. We have to arrange the given rational numbers in ascending order. The first part 1 is 4 by 9 minus 5 by 12, 7 by minus 18 and minus 2 by 3. So first we have to convert all the rational numbers to their standard form. So 4 by 9, the denominator is negative, so it will become minus 4 by 9 in standard form. 5 minus 5 by 12 is already in standard form. 7 by minus 18, the denominator is negative. To make it positive, it will become minus 7 by 18, and minus 2 by 3 is already in standard form. So now we see all the rational numbers are negative. There are 4 rational numbers and the denominators are all different. So we have to first find the LCM of all the denominators. Now what will be the LCM of all the denominators? How do we find the LCM of some numbers? We do like this: 9 hyphen 18 and 3. We first divide all the numbers with the least prime number, which we can see is 3. This is 3, is 4, 6, 1. Then we see we can again divide by 3. This is 1, this is 4, this is 2, this is 1. Then we can divide by 2. This is 1, this is 2, this is 1, and we have remaining 2. So the LCM will be LCM of 9, 12, 18 and 3 is 3 into 3 into 2 into 2. That is 9, 18, 36. The LCM is 36. So we have to convert all these 4 rational numbers to their equivalent form, so that all the equivalent rational numbers will have common denominator as 36. So what will be minus 4 by 9? Its equivalent form, so that the denominator is 36. We will have to multiply both the numerator and the denominator by 4. So it becomes minus 16 by 36. Minus 5 by 12, we have to multiply both the numerator and the denominator with 3. So it becomes minus 15 by 36. Minus 7 by 18, we have to multiply both the numerator and the denominator with 2. So it becomes minus 14 by 36. And minus 2 by 3, we have to multiply both the numerator and the denominator with 12. So it becomes minus 24 by 36. Now all the 4 rational numbers have same denominator 36. We will now have to compare them based on their numerators, and we can clearly see if we arrange the numerators, we can see in ascending order we get minus 24 will be less than minus 16, will be less than minus 15, will be less than minus 14. So this implies minus 24 by 36 will be less than minus 16 by 36 will be less than minus 15 by 36. This will be less than minus 14 by 36. So now we can do the arranging of the original rational numbers in ascending order. Like minus 24 by 36, the original rational number was minus 2 by 3, and minus 16 by 36, the original rational number was minus 4 by 9. Minus 15 by 36, the original rational number was minus 5 by 12, and minus 14 by 36, the original rational number was 7 by minus 18. So this is the ordering in ascending order of the given rational numbers. Okay. Let's do part 2. Part 2 says the rational numbers are minus 3 by 4, 5 by minus 12, minus 7 by 16, and 9 by minus 24. First, we have to convert all the 4 rational numbers to their standard form. Minus 3 by 4 is already in standard form because the denominator is positive and the HCF and the numerator and the denominator, that is absolute value of the numerator and the denominator, is the common divisor of the absolute value of the numerator and the denominator is 1. Now 5 by minus 12, it is not in standard form, as the denominator is negative. To make it positive, it will become minus 5 by 12, which is in standard form. Minus 7 by 16 is already in standard form, and 9 by minus 24, the denominator is negative. So to make it positive denominator, we will have minus 9 by 24. But minus 9 by 24 is not in standard form. It is not in standard form, as the common divisor of 9 and 24 is 3. So we have to convert it to standard form by dividing both the numerator and the denominator with 3. So this becomes minus 3 and this becomes 8. So we have the rational numbers minus 3 by 4, minus 5 by 12, minus 7 by 16 and minus 3 by 8. So now we see that all these rational numbers are negative and the denominators are different. We have to find the LCM of the denominators. So 4, 12, 16 and 8, we divide it with the least prime number, which is let's say is 2. This is 2, 2 minus 6 minus 8 minus 4. We divide it again by 2, 1, 3, 4, 2. We divide it with 2 minus 1, 3, 2, 1. So the LCM of 4, 12, 16 and 8 is 2 into 2 into 2 into 3 into 2. This is this will be 48. This is 48. So the LCM is 48. So now we have to convert all these 4 rational numbers to their equivalent form, so that all the equivalent rational numbers will have a common denominator of 48. So minus 3 by 4, we will have to multiply both the numerator and the denominator with 12. So this becomes minus 36 by 48. Minus 5 by 12, we have to multiply both the numerator and the denominator with 4. So it becomes minus 20 by 48. Minus 7 by 16, we have to multiply both the numerator and the denominator with 3. So this becomes minus 21 by 48. And minus 3 by 8, we have to multiply both the numerator and the denominator with 6. So this becomes minus 18 by 48. So now we have all the rational numbers with common denominator 48. We will now compare them based on the numerators, and we can clearly see that the numerators arranged in ascending order will be minus 36 is less than minus 20 is less than minus 36 is less than minus 21 will be less than minus 20 will be less than minus 18. So this implies minus 36 by 48 will be less than minus 21 by 48 will be less than minus 20 by 48 will be less than minus 18 by 48. So now we can finally say the ordering of the original rational numbers in ascending order. So minus 36 by 48, the original rational number was minus 3 by 4, and minus 21 by 48 minus 21 by 48, the original rational number was minus 7 by 16. Minus 20 by 48, the original rational number was minus 5 by was 5 by minus 12, and finally minus 18 by 48, the original rational number was 9 by minus 24. So this is the ordering of the given rational numbers in ascending order. Okay. I do not think I should be doing 3 and 4, because you already got an idea what is the concept or steps applied in arranging a given rational numbers in ascending order. Now let's do question number 9. Let's do two problems, two parts from question number 9. So this we have to arrange the given rational numbers in descending order. So even though the concept, the logic is same, at the last step you just have to compare the numerators and arrange them in the descending order. So let's do 9 part 1. The rational numbers given are minus 2 by 1, we can consider it as minus 2 by 1, minus 13 by 6, 8 by minus 3 and 1 by 3. So first we have to convert the given rational numbers to the standard form. So minus 2 we can write it as minus 2 by 1, which is already in standard form. Minus 13 by 6 is already in standard form. 8 by minus 3 is not in standard form because the denominator is negative. To make it in standard form, it will become minus 8 by 3, and 1 by 3 is already in standard form. Now we see that there are 3 negative rational numbers and 1 positive rational numbers. So the positive rational number 1 by 3 obviously will be the greatest one. So it will be something like 1 by 3, 1 by 3 will obviously be greater than all the 3 other rational numbers. Now we have to see, arrange these 3 rational numbers in descending order. So let's work on these 3 rational numbers. So we have minus 2 by 1, minus 13 by 6 and minus 8 by 3. We have to convert them to their equivalent rational numbers so that the common denominator will be the LCM of 1, 6 and 3, which is 6. So the rational number minus 2 by 1 in its equivalent form, so that the denominator is 6, will become, we will have to multiply both the numerator and the denominator with 6. So it becomes minus 12 by 6. Minus 13 by 6, we have to multiply both the numerator and the denominator with nothing, because the denominator is already 6. Minus 8 by 3, we have to multiply both the numerator and the denominator with 2, so it becomes minus 16 by 6. So now we see these 3 rational numbers have same common denominator as 6. We now compare them based on the numerators, their numerators in descending order, because we have to, the question is about arranging the given rational numbers in descending order, that is from largest to smallest. So we know that in minus 12, minus 13 and minus 16, the ordering in descending order will be minus 12 greater than minus 13 is greater than minus 16, and hence this will imply that minus 12 by 6 is greater than minus 13 by 6 is greater than minus 16 by 6. Okay, so finally we can say that the ordering of the given rational numbers in descending order will be 1 by 3 is the largest one, then it is minus 12 by 6, where the original rational number was minus 13 by 6, then is the minus 13 by 6, and the original rational number was I did something wrong. No, it's fine. So 1 by 3 is greater than minus 12 by 6. Minus 12 by 6, the original rational number was minus 2 by 1. The original rational number of minus 12 by 6 was minus 2. Then we have minus 13 by 6. Minus 13 by 6, the original rational number was minus 13 by 6 only. And we have last minus 16 by 6 is the smallest rational number, and the original rational number of minus 16 by 6 was 8 by minus 3. So this is the ordering of the given rational numbers in descending order. Okay, I will do. Let's do part 2. We have the rational numbers. Given rational numbers are minus 3 by 10, 7 by minus 15, minus 11 by 20, and 17 by minus 30. So first we have to convert all the rational numbers to their standard form. So minus 3 by 10 is already in standard form. 17 by minus 15, the denominator is negative. So to make that positive, it becomes minus 7 by 15. Minus 11 by 20 is already in standard form. And 17 by minus 30, we have to make the denominator positive. So it becomes minus 17 by 30. Now we see all the rational numbers are negative and the denominators are different. So we have to first find the LCM of the denominators. So let's say 10, 15, 20 and 30. If we divide with the least prime number, which divides the maximum number of these numbers is 3. So this is 10, 5, 20 and 10. Then we can divide by 2. This is 5, this is 5, this is 10, this is 5. We can again divide by 2, 5, 5, 5, 5, and then we can divide by 5, 1, 1, 1, 1. So LCM of 10, 15, 20 and 30 is equal to 3 into 2 into 2 into 5. This is 60. The LCM is 60. Okay. So we have these 4 rational numbers. They are all negative and they are having different denominators, and the LCM of the denominators is 60. So we have to convert all these 4 rational numbers to their equivalent form, so that all the equivalent rational numbers will have a common denominator as 60. So minus 3 by 10, we will have to multiply both the numerator and the denominator with 6. So this becomes minus 18 by 60. Minus 7 by 15, we have to multiply both the numerator and the denominator with 4, and it becomes minus 28 by 60. Similarly, minus 11 by 20 will become, we will have to multiply both the numerator and the denominator with 3, becomes minus 33 by 60. And minus 17 by 30, we have to multiply both the numerator and the denominator with 2. So it becomes minus 34 by 60. So now we have all the rational numbers with the common denominator as 60. We will now compare them based on their numerators in the descending order. So we see minus 34 in descending order. Okay. In descending order, it will be minus 18 is greater than minus 28 is greater than minus 33 is greater than minus 34. So this implies minus 18 by 60 is greater than minus 28 by 60 is greater than minus 33 by 60 is greater than minus 34 by 60. Now we can tell about the ordering of the original rational numbers in descending form. Minus 18 by 60, the original rational number was minus 3 by 10. Minus 28 by 60, the original rational number was 7 by minus 15. And minus 33 by 60, the original rational number was minus 11 by 20. And minus 34 by 60, the original rational number was 17 by minus 30. So this is the ordering of the rational numbers, given rational numbers in descending order. Okay. Question number 9. Let's do the last one, that is part 4. Let's do part 4. The rational numbers are minus 10 by 11, minus 19 by 22, minus 23 by 33, and minus 39 by 44. Now we see that all the rational numbers are already in standard form, because the denominators are negative or positive, and there is no common divisor between the numerator and the denominator for all the rational numbers. So we have to find the LCM of the denominators, that is 11, 12, 33 and 44. So let's first divide by 2. This is 22. So we have 11 minus 11, 33 minus 22. We again divide by 2. We get 11, 11, 33, 11. Then we divide by 3. We get 11, 11, 11 and 11. And finally we divide by 11. We get 1, 1, 1, 1. So the LCM of 11, 22, 33 and 34 is equal to 2 into 2 into 3 into 11. This is 33 into 4, that is 132. This is the LCM. Okay. Now we have to convert all these rational numbers to their equivalent form, so that all the equivalent rational numbers will have the common denominator as 132. So for minus 10 by 11, we have to multiply both the numerator and the denominator with 2 into 2 into 3. So it becomes minus 10 into, we have to multiply to make 11 to 132, we have to multiply 11 with 2 into 2 into 3. So we have to multiply the numerator also with 2 into 2 into 3. So 2 into 2 into 3 is 12. And we have 11, we have here 132. Now minus 19 by 22, we have to 22, if we multiply 22 with 6, we get 132. So the minus 19 by 22, its equivalent form will be minus 19 into 6 divided by 132. Similarly, minus 23 by 33, if you multiply 33 with 4, we get 132. So the equivalent form will be minus 23 into 4 by 132. And finally, minus 39 by 44, if you multiply 44 with 3, you get 132. So the equivalent form of minus 39 by 44 will be 39 into minus 39 into 3 divided by 132. So now the given rational numbers becomes minus 120 by 132. This is minus 114 by 132, and this is minus 96 by 132, and finally minus 117 by 132. So these are the rational numbers. They all have common denominator as 132. Now we have to compare based on their numerators in the descending order. So it will be minus 96 is greater than minus 114 is greater than minus 117 is greater than minus 120. So this implies minus 96 by 132 will be greater than minus 114 by 132 will be greater than minus 117 by 132 will be greater than minus 120 by 132. So the ordering of the original rational numbers in descending order becomes minus 96 by 132. The original rational number was minus 23 by 33. minus 114 by 132, the original rational number was minus 19 by 22. Minus 117 by 132, the original rational number was minus 39 by 44. And minus 120 by 132, the original rational number was minus 10 by 11. So this is the ordering of the given rational numbers in descending order. Okay. So I am skipping a few problems because they are very similar to the other problems. I hope you are getting the concepts that I am applying to solve the problems. And for the question number 8 and 9, if the concepts applied in sorting, in arranging the given rational numbers will be the same. For descending order, you have to just compare the final rational numbers based on the numerators, the descending order, and for that ascending order, you have to compare the numerators. In the final step, you have to compare the numerators based on you have to arrange the numerators based on in the ascending order. Okay. Now question number 10. Question number 10 are true and false statements. These are, I think, true. Which of the following statements are true and which are false? Every whole number is a rational number. Every whole number is a rational number. This is true because every whole number is a rational number. This is true because 0 can be written as 0 by 1. 1 can be written as 1 by 1, and 2 can be written as 2 by 1. So likewise, we can write all the whole numbers. We can in the form of rational number p by q, where p will be the whole number and q will be 1. So it goes on. So this is true. Every whole number can be written in the form p by q, where q will be 1 and p will be the whole number. Okay. Part 2, every integer is a rational number. This is true because every integer can also be n. For integer n can be written as n by 1, which is in the form p by q, where q equals to 1. So this is also true. Third says 0 is a whole number but it is not a rational number. 0 is a whole number but it is not a rational number. This is false because 0 is a whole number, that is fine, but 0 can always be written as 0 by 1, which is of the form p by q, where p equals to 0 and q equals to 1. In rational number, rational number is in the form p by q, where q is not equals to 0, where p and q are integers. So 0, we can write 0 as 0 by 1. So we know that the q is which is 0 by 1 is in the form p by q, where q is equal to 1 and p is equal to 0, which is totally fine. Hence 0 is a whole number and it is also a rational number. So it is part 3 is a false statement because it says that 0 is a whole number but it is not a rational number. Okay. So this brings to an end in solving all the problems of exercise 1A. I hope this video was beneficial and you understood the concept of applying the concept of properties of how we apply the properties of rational numbers and the concept of comparing to rational numbers in solving the problems of exercise 1A. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video I will start the chapter. I don't know the chapter, I have to see the textbook, what is the next chapter? Let me quickly check it. The next chapter is exponents from the textbook of author RS Aggarwal. And please note that there will be a new playlist, concepts to remember maths 8, where I will prepare and upload videos based on the series of concepts to remember, where I only discuss about the key concepts of a particular chapter, and topic wise, that is concepts to remember videos of a particular chapter will be divided into several topics, and each topic will have a set of sample problems that will evaluate your understanding on the concepts of the particular topic. So those videos will be very, very useful. You can use those videos as a checklist to verify that your concepts of a particular chapter is up to the mark. So please stay tuned for also those videos, which will be in a separate playlist, concepts to remember maths 8. So thanks for watching, and until the next video, take care and bye.